Hi students, so now let us continue with the exercise 1.1. So we have finished up to the 9th exercise questions. So we are continuing with the 10th question. So 10th question, they are asking some of the random examples for certain types of the relation. So in that first one, we need to give one of the examples such that the relation should be symmetric, but it should neither be reflexive nor be transitive. So which it is not reflexive, but it should be symmetric and it should not be transitive. So we need to give example for this type of relation. Suppose if I consider a set A with 5, 6, 7 has its element. So if I consider a set A with the elements 5, 6, 7 and I am defining a relation on that set A has R is equal to 5, 5, 6 and 6, 7. I defined a relation like this. So you can see here, this is a relation which is defined by me itself here. So you can see here clearly, to say it is a reflexive means we should have 5, 5, 6, 6 and 7, 7 in the relation, but there is none of this in the relation, so it is not reflexive. To say it transitive, there is 5, 6 and 6, 7. It is belonging to the relation, but that is 5, 7. It is not belonging to the relation, so the relation is not transitive. But for 5, 6, there is ulta of that one, that is not 6, 7. It is 5, 6 and 6, 5. Sorry, I have written the relation wrong. Even here also 5, 6, 6, 5. So it becomes 5, 5. Sorry for the mistake. So for 5, 6 it's ulta, 6, 5 is also belonging to the relation, and for 6, 5 it's ulta, that is 5, 6 also belonging to the relation. So the given relation is symmetric. So this relation is nothing but a random example which is symmetric, but it is not a reflexive as well as it is not a transitive. So the next one is, they are asking which is transitive but neither reflexive nor symmetric. So it is not reflexive, not symmetric, but it should be a transitive relation. So upon the set of real numbers, I am defining a relation R such that it is in the form of A, B and A is strictly less than B. This is the what relation I am defining here. So first thing I need to say, it is not a reflexive. So if I need to say it is reflexive, clearly if I take A, A means, what does that implies? A is less than A, which is not at all possible. A number cannot be less than itself for each of the number which is belonging to the set of real numbers. So A, A implies A is less than A, which is not at all possible. So A, A does not belongs to the relation R. So it is not a reflexive relation. And to say it's symmetric, suppose if I take any two numbers A, B, which is belonging to this relation, means what does that implies? A is less than B. What we need to say it as a symmetric, B, A also should belong to A. Suppose if I take B, A also, means what does that say? B is less than A. Suppose if A is strictly less than B, means B cannot be strictly less than A, because it is not at all possible, because A is less than B means B cannot be less than A. So B is not less than A means what does it says? B, A does not belongs to R. So the thing what we are expecting, B, A, whether it is belonging to R or not, we can say that B, A does not belonging to R. So the relation is not symmetric. Now to say it is a transitive, if A, B belongs to R and B, C belongs to R, means what does that implies? A is less than B, and for this relation it implies B is less than C. So if I club these two, what happens? A is less than C itself, because I can write it singly as A is less than B and B is less than C. It implies A is less than C. If A is less than C means what does that implies? a comma c, that is belonging to the relation. So now you can see here, if a comma b and b comma c belongs to the relation, means a comma c is also belonging to the relation. So the given relation is a transitive now. So this example or this relation will say that it is a transitive but neither reflexive nor symmetric. For the symmetric, you can take with any random example also instead of taking a comma b here. Like suppose if I take 1 comma 2, which is belonging to the relation, means what does that implies? 1 is less than 2. So whether 2 is less than 1? No, 2 is not less than 1 means what? 2 comma 1 does not belongs to the relation. So with random example also you can say it. Either with this one also you can say it has not a symmetric. So the next is, we need to say, take one of the examples such that the relation, it should be a reflexive as well as symmetric, but it should not be transitive. So I am taking with one of the random set A is equal to 4, 6, 8 here. Okay, so first thing, it should be reflexive. I am taking relation as it is. You can observe here how I am writing the relation. So I am saying it is a reflexive. Reflexive means the doublets of all the elements present in the set should be existed. So I will take doublets of all the elements, 4 comma 4, 6 comma 6, 8 comma 8. So this relation is now perfectly reflexive, symmetric as well as transitive. But what we think we should get, which is not a transitive. So but it should be symmetric. So what I am doing next is, if I take 4 comma 6 and 6 comma 4, what happens now? 4 comma 6 is there, it's ulta 6 comma 4 is also existing, so it is a symmetric. And if I go with transitive, means 4 comma 6, 6 comma 4, 4 comma 4 is also existing, so even now this one is a transitive also. So we should think of another ordered pair so that it should be symmetric but not transitive. So I am going with 6 comma 8, and writing only 6 comma 8, we are not satisfying the symmetric, so 8 comma 6 also I am writing. Now you can see here, 6 comma 8, 8 comma 6, the ulta of both the ordered pair is also existing, it is symmetric. To check now whether it is a transitive or not, you can see here 4 comma 6 is there, 6 comma 8 is there, but 4 comma 8 is not at all existing, so it is not a transitive. You can see here clearly with all these three pair, you can say it is a reflexive. With ulta of each ordered pair, 4 comma 6, 6 comma 4 and 6 comma 4, 4 comma 6, 6 comma 8, 8 comma 6, 8 comma 6, 8, 6 comma 8, with all these ordered pairs you can say it is a symmetric. With these two ordered pair, that is 4 comma 6 belonging to the relation and 6 comma 8 is also belonging to the relation, but our 4 comma 8 is not at all belonging to the relation. So with this ordered pair, I can say this relation is not a transitive. So this is how we are taking the random examples to frame the relation according to the given thing. So this is how we are taking the relation. So let us move to the next one. So the next is, which is reflexive and transitive but not symmetric. Again I am defining here relation on the set of real numbers. So you can take, if a set of real numbers means I am defining that set of real numbers, defining a relation as a comma b such that a cube is greater than or equal to b cube. So you can see here clearly a cube is greater than b cube. Clearly a comma a, it is belonging to the relation, because if I take any number and compare that number with itself, that is a cube which is greater than or equal to a cube. Here one number is compared with itself along with this equal symbol. I can say that it is this relation is going to satisfy for all the elements of the set of real numbers. So the relation is a reflexive relation. And if I need to talk about, it is saying set transitive also. If I take, if a comma b belongs to R and b comma c belongs to R, means what does that implies? A comma b belongs to R means a cube is greater than or equal to b cube. what does this implies? B cube is greater than or equal to C cube. Suppose if I club these two, what we are going to get? That is A cube is greater than or equal to B cube and B cube is greater than or equal to C cube. By looking into this, I can say that A cube is greater than or equal to C cube. So if A cube is greater than or equal to C cube means what does that implies? A comma C belongs to the relation R. If A, now you can see here A comma B, B comma C belongs to the relation, and that implies A comma C belongs to R means the given relation is a transitive relation. Now suppose if I am taking, now they are saying it should not be symmetric. Now you can take one of the random example. Suppose 2 comma 1 belongs to the relation means what does that implies? 2 cube is greater than or equal to 1 cube. Yes, obviously 2 cube is 8 is greater than or equal to 1. Yes, this is true. But what about 1 cube which is greater than or equal to 2 cube? No, it is not at all possible because 1 is not at all greater than 8. So 1 is not at all greater than 8. 1 is less than 8. So this implies what? 1 comma 2 does not belongs to the relation. So if 2 comma 1 belongs to R and its ulta 1 comma 2 is not at all belonging to the relation means the given relation is not at all symmetric. The next is symmetric and transitive but not reflexive. So suppose if I take a random set with thing 5 and 6 and I define a relation like 5 comma 6. So here they are saying it should be symmetric. So if I take 5 comma 6 means 6 comma 5 also should be needed to be existed, and they are saying it should be transitive also. So 5 comma 6, 6 comma 5 exist in the relation means 5 comma 5 also need to be existed in the relation. Now this relation you can see it clearly, it is symmetric because for 5 comma 6, 6 comma 5 is also there, and for 6 comma 5, 5 comma 6 is there. So and for 5 comma 5 the ulta is 5 comma 5 itself, so it is a symmetric. To say it is transitive, 5 comma 6, 6 comma 5 exist in the relation means 5 comma 5 is also existing in this relation. So it is a symmetric and transitive, but it is not at all reflexive because 6 comma 6 is not at all belonging to this relation. So it is not a reflexive. So this is how if we are taking the random example means we are dealing like this. So in these examples you can see here for the second one and the fourth one I have took with the random general example like A is less than B, A cube is greater than or equal to B cube. So even for these also if we are going with some of the random like what we have did for 1, 3 and 5th question. So similarly what is this saying? Transitive but neither reflexive nor symmetric. So it means it should be transitive but it should not be reflexive and symmetric. Suppose if I consider a set A with 1, 2 and 3. Now what is I am taking defining a relation in such a way that it should be transitive. So how I am dealing with 1 comma 2, 2 comma 3 and 1 comma 3. Why 1 comma 2, 2 comma 3, 1 comma 3. So now this relation is what? This relation is a transitive relation. You can see here because for 1 comma 2, 2 comma 3, 1 comma 3 is existing. So this relation it is a transitive, but this is not reflexive because it is not consisting of 1 comma 1, 2 comma 2 as well as 3 comma 3 is not at all belonging to the relation. So it is not at all reflexive. So and it is not at all symmetric because for 1 comma 2 it is belonging to the relation means, but 2 comma 1 it is not at all belonging to the relation. So it is not at all a symmetric. So this relation it is a transitive but neither reflexive nor symmetric. So this is how with the random example and for the second question, and for this one which is reflexive and transitive but not symmetric. Reflexive, symmetric, transitive, which is reflexive and transitive but not symmetric. So for this set itself I am dealing, if I define a relation R such that it should be reflexive. Reflexive means what? The doublets of all the element present in the set it should be existed. So I have written now all the doublets. Now the next is it should be transitive. So what I am doing is 1 comma 2, 2 comma 3 and 1 comma 3. I am writing. Yes, obviously this is a transitive, because you can see here for 1 comma 2, 2 comma 3 is there. 1 comma 2 and 2 comma 3 are belonging to the relation. So 1 comma 3 is also belonging to the relation. Even you can compare these elements with this doublet also. You know, if any ordered pair is compared with the doublets, means we are going to get the same ordered pair itself. So this relation is now reflexive relation, because we are having the doublets of all the elements in the given set, and it is a transitive also because it is satisfying the condition of transitivity. But it is not a symmetric, because if 1 comma 2 is belonging to the relation, means 2 comma 1 is not at all belonging to this relation. So it is not at all a symmetry. So all these examples here, what is the thing is, I am telling you how these examples are. The first thing you need to understand here is, first try to take your own example, try to understand the concept and take yourself one of the example. At that time you people will understand all these examples step by step. So in the beginning you might feel difficult how these examples will be, but upon practicing, upon concentrating upon these concepts, all the concepts are going to be get clear. And this question, 10th question, where I took this example, this is very important question. So that's why I have did in all the ways how you can take the examples, even in the general manner, even with the help of a set. In all the way I have given you examples for your understanding. So take your own example, consider one set and try to take yourself example satisfying those relations. So once you understand the concept, means taking these examples is not at all a big thing. But the thing is, you need to understand the concept step by step with the full of involvement in this concepts. So now let us move to the next question. So the next question, what it is saying is, they have considered a set A which is consisting of set of all points in a plane, and they have defined the relation R is equal to P comma Q such that the distance of the point P from the origin is equal to the distance of the point Q from the origin. Suppose if I take this one as O, which is nothing but origin means, and this is any point P in the plane and this is any point Q in the plane, means they are saying we are picking those points in a plane. If I consider this book as a plane, means we are picking up those points in a plane such that the distance of that point from the origin are equal. That is the distance of this point. If I pick the point P and Q, means the distance of the point P from the origin and the distance of the point Q from the origin both are equal. That is what the relation is saying. So we need to prove that this relation is an equivalence relation. So for to prove it is equivalence, it should be reflexive, symmetric and transitive. So let us check for reflexive. So clearly P comma P belongs to this relation. So P comma reflexive means what? Whatever the point we are taking, we need to compare that point with itself. So P comma P belongs to R means we are picking point P, which is any point in this plane. Then clearly OP is equal to OP itself, right? The distance of the point P from the origin is equal to, this distance is equal to itself. So this is what the relation is saying. So OP is equal to OP, which is satisfying this relation. So this point P, that P which is satisfying for all points which is belonging to the set A. So this relation is a reflexive relation. Then let's check for symmetric relation. So if OP is equal to OQ. So if OP is equal to OQ means this is what the relation is saying. So OP is equal to OQ means the distance of the point P from the origin is equal to the distance of the point Q from the origin. So if OP is equal to OQ means what does that implies? OQ is equal to OP. So OQ is equal to OP means what does we can say? Q comma P, it is also belonging to the relation. So if P comma Q belongs to the relation means that implies OP is equal to OQ. what is OP is equal to OQ? The distance of the point P from the origin is equal to the distance of the point Q from the origin. So I can state that statement is also equal to the distance of the point Q from the origin is equal to the distance of the point P from the origin. So if it is so means then QP or it is also equal to OQ is equal to OP. That implies QP belongs to the relation. So if PQ belongs to the relation means QP also belonging to the relation. So the relation, it is a symmetric relation. So now to say it has a transitive. If PQ and QR belongs to the relation R means what does that implies? OP is equal to OQ, and what does this implies? OQ is equal to OR. The distance of the point P from the origin is equal to the distance of the point Q from the origin, and this is saying that the distance of the point Q from the origin is equal to the distance of the point QR from the origin. So if I club these things means I can write OP is equal to OQ and OQ is equal to OR. So upon this I can state it has OP is equal to OR. So if OP is equal to OR means the distance of the point P from the origin is equal to the distance of the point R from the origin. That implies P comma R is also belonging to the relation. So you can see here when PQ and QR belongs to the relation means PR is also belonging to the relation. So the given relation, it is a transitive relation. So our agenda to say it is an equivalence. So it is a reflexive, symmetric and transitive. So the given relation is an equivalence relation. And further in this question they asked us to show that the set of all points related to the point P is a circle passing through the point P with the origin center, with the origin as the center. So you can see here with this above relation, if I take all those points, if this is the origin and I need to say that we need to collect set of all those points such that the distance OP must be equal to OQ. If I take any point instead of Q, if I take R means then also that distance from the origin OP must be equal to OR. If I take any point means this distance must be equal to all those points. So if I take all those points, so these will become the set of all those points. Suppose if I call this point as P means and this distance is equal to OP means, now I need to collect all those points such that it should be equal with the distance OP. So all those points will become these points. If I take P1, P2, P3, P4 means set of all these points becomes our set of all points. If I join all those points means we are going to get a circle which is passing through the point P with the center origin. So this is what we needed to show. So we have showed it. So that is nothing but here OP, it is equal to set of all those points in the plane such that the distance of OP must be equal. We know the property of the circle. What does it is saying? All these distances are equal, right, which is nothing but the radius of the circle. So that is what we are saying. So all these distances are equal, and if we club all those points means it becomes a circle which is passing to the point P, and the center of that is nothing but a origin. So this is our 11th question. So now let us move to the next question. So they have given a set which is nothing but a set of all triangles, and they have considered a relation such that T1 and T2. From this set if we take any two means it will be triangle itself. So that if we relate those two triangles means then those two triangles must be the similar triangle. So what we need to show that now here first we need to show that this relation is an equivalence relation. So clearly we know that any triangle is similar to itself. Any triangle is similar to itself. So if I take any triangle T which is belonging to the set A means then obviously T comma T belongs to that relation because T is similar to T itself. So if any triangle is similar to itself, we know this fact. So for all T which is belonging to the set A, this is going to be satisfied. So the given relation is an reflexive relation. Now to check for symmetry. So to checking for symmetric, if I take any two triangles, suppose if T1 and T2 belongs to the relation means what does that implies? T1 is similar to T2. If T1 is similar to T2 means even T2 is also similar to T1. So if T2 is similar to T1 means what does that implies? T2 and T1 belongs to the relation. So if T1 and T2 belongs to the relation, T2 and T1 is also belongs to the relation. So the given relation is a symmetric. Now to checking for transitive relation. Suppose if I take T1 and T2 which is belonging to the relation and T2 and T3 which belongs to the relation. So if these two belongs to the relation means what does that implies? For this implies T1 is similar to T2 and this implies T2 is similar to T3. If I club these two, what happens? T1 is similar to T2 and T2 is similar to T3. So from this we can say that T1 is similar to T3. So T1 is similar to T3 means what does that implies? T1 and T3, this is belonging to the relation R. So if T1, T2, T2, T3 belongs to the relation means T1, T3 also belongs to the relation. So the given relation is a transitive relation. So the relation is reflexive, symmetric and transitive. So the relation is an equivalence relation. Further, the extension of this question itself, they have given us three right angled triangles, that is T1 with the sides 3, 4, 5, T2 with the sides 5, 12, 13 and T3 with the sides 6, 8, 10. So right angle triangle, I am not doing right angle triangle. So if I am go with this order 3, 4, 5 which is nothing but T1, another triangle 5, 12, 13 which is our triangle T2 and T3 with the order 6, 8, 10. So they have given us the three triangle and asked us to find which among these three triangles are related to each other. So related means which relation? This relation itself. So related to each other means in this which two triangles are similar to each other. Whether T1 is similar to T2 or T1 is similar to T3 or T2 is similar to T3. We need to check that one. So how we are going to check whether these three, among these three, which two triangles are similar to each other or related to each other means the ratio of their sides, corresponding sides. So you can see here, if I take the ratio of this one 3 with 5, 4 with 12, respective sides itself. So I have taken in the same order 3, 4, 5, 5, 12, 13, 6, 8, 10. 3 with 5, 4 with 12 and 5 with 13. Whether these ratios are same, you need to check it once. So what does this is going to give us? 1 by 3. So this is not at all 1 by 3 form and this one is also not at all in the 1 by 3 form. So this ratio is not, we are not going to get a same ratio. Now let us compare T1 and T3. This is comparison, the ratio is compared with T1 and T2. Now I am comparing ratio with T1 and T3. So what does that is saying? 3 with 6, 4 with 8, 5 with 10. 3 with 6, 1 by 2, 4 with 8, 1 by 2, 5 with 10, 1 by 2 which is equal to 1 by 2. So the ratio of all the sides of the triangle which is equal to 1 by 2. So the ratios are same. So T1 is similar to triangle T3. So these two triangles are related to each other. So this is how we are checking with the above related relation. So this is about the 12th question. So let us move to the next question. So next question, what it is nothing but they have given a set of all polygons. So set of all polygons means what? It includes the set of all triangles, quadrilaterals, pentagons, hexagon, heptagons, octagons, decagons. So it is consisting of all the types of polygons from which is having all this consisting of the different sides of polygons. So from that set, if I take any two polygons, from that set if I take any two polygons means, then if those two polygons having same number of sides means, then we take that two polygons in one relation. So that is what the relation is saying. So P1 and P2 are any two polygons from the set A. So if I take any two polygons from the set A means if it is having same number of sides means then those two polygons will belongs to the relation R. For example, if I take P1 and P2, if P1 and P2 both the polygons is having 3 sides, that is triangle. 3 sides means we are going to get triangle itself. So if both the polygons are triangle means then it is going to belong to relation R, like that. So what we need to prove first? First we need to prove this relation is an equivalence. For that first we need to check for reflexive. So we can compare. Reflexive means if I take P comma P, here in the reflexive relation we are comparing any polygon with itself. So we can, if I compare any polygon with itself means it is having clearly P comma P belonging to the relation, because it is having same number of sides itself. Because P it is having n number of sides means again P, that is that polygon itself, it is also having n number of sides. So both are having same number of sides. So P comma P belongs to the relation, so which is satisfying for all P which is belonging to the set A. So the given relation is a reflexive relation. Now we need to check for symmetry. Suppose if I take, if P1 comma P2 belongs to the relation means what does that implies? P1 and P2 are having same number of sides. So P1 and P2 are having same number of sides means P2 and P1 is also having same number of sides. So P1 and P2 are having same number of sides means what does that implies? P2 comma P1 belongs to the relation. So if P1 comma P2 belongs to the relation means P2 comma P1 is also belongs to the relation. So the given relation is a symmetric relation. Now I need to check for transitive. If P1 comma P2 and P2 comma P3 belongs to the relation means what happens? What does this implies? P1 and P2 are having same number of sides. What does this implies? P2 and P3 are having same number of sides. If I club these three means P1, P2 and P3, all the three polygons are having same number of sides. So by this what I can say? P1 and P3 is also having same number of sides. So P1 and P3 are having same number of sides means what does that implies? P1 comma P3, this is belonging to the relation. So clearly if P1 comma P2 and P2 comma P3 belongs to the relation means P1 comma P3 is also belonging to the relation. So the given relation is a transitive relation. So the relation is reflexive, symmetric and transitive. So it is an equivalence relation. Further in this question they are asking what is the set of all elements in A related to the right angle triangle T with 3, 4, 5. So they have given one of the right angle triangle with the sides 3, 4, 5. So they are asking from the set A, which is consisting of set of all polygons, from this set which and all elements are related to this triangle 3, 4, 5, which is a right angle triangle. So right angle triangle, it belongs to which category? It belongs to the category triangle because it is having 3 sides. So from this set which is consisting of polygon, which and all elements are going to related to this triangle? It is nothing but from the polygon, set of polygons, we are going to get a set of all triangles which are related to the triangle T with right angle triangle 3, 4, 5. Even they have mentioned specialized right angle triangle. From the set of polygons, we are not only taking the set of right angle triangles. Note this one. From the set of polygons, I am taking set of all the triangles. It might be equilateral or it might be isosceles triangle, whatever the types of triangle may be. So from the set of polygons, I am taking set of all the triangles, because even the equilateral triangle, it is also belonging to the set of triangle. Here the relation is given only upon same number of sides. They are not given any other specialization in the relation. They have mentioned the relation with only same number of sides. So right angle triangle is also having 3 sides, and set of all the triangles, it is also having 3 sides. So we need to consider only this relation, that is same number of sides. So from the set of polygons, I am taking set of all triangles. So this is regarding the 13th question. So let us move to the next question. So the next question, it is saying we are considering the set of all lines in the xy plane. Suppose if I consider the xy plane, means from that xy plane we are considering set of all the lines. So what is the relation they are saying? If we take any two lines, means from the xy plane, then those two lines must be parallel. So we need to show this relation as an equivalence relation. So for that, first I will check with, first we will prove this one, later we move to the next thing. To say it is a reflexive. So the thing is, in the reflexive relation we are checking with itself. So we know that earlierly, that is any line is parallel to itself. Any line is parallel to itself. So this is the known concept. So any line is parallel to itself means if I take any line L which is belonging to the set L, means then L comma L belongs to the relation because L is parallel to L itself. So what does that implies? For all L which is belonging to the set L, L comma L belongs to the relation. So the given relation is a reflexive relation. Next, let us check for symmetry. So if L1 comma L2 belongs to the relation, means what does that implies? L1 is parallel to L2. So if L1 is parallel to L2 means we can also say that L2 is parallel to L1. So if L2 is parallel to L1 means what does that is saying? L2 comma L1 belongs to the relation. So if L1 and L2 belongs to the relation means L2 and L1 is also belonging to the relation. So the relation is a symmetric. Next, checking for the transitive. So if L1 and L2 and L2 and L3 is belonging to the relation means what does this implies? L1 is parallel to L2. And what this ordered pair is saying, L2 is parallel to L3. Now clubbing these two, what I can say that L1 is parallel to L2 and L2 is parallel to L3. By this three, what I can say that now clearly L1 is parallel to L3 also. If L1 is parallel to L3 means what does that implies? L1 comma L3 belongs to the relation. So if L1, L2 and L2, L3 belongs to the relation means L1 and L3 is also belonging to the relation. So the relation is a transitive. So the given relation is reflexive, symmetric and transitive. So it is an equivalence relation. Further, what they asked, we need to find the set of all lines related to the line y is equal to 2x plus 4. So here related means what is the relation? So we need to find set of all lines such that all those lines must be parallel to this line. So we know that if any two lines are said to be parallel means, if any two lines are said to be parallel means, from the straight line concept which we have studied in the class 11th, if we need to say if any two lines are parallel means then its slope must be same. It should have the same slope, that is slope we are representing by m. So this m must be equal. So here the line it is given y is equal to 2x plus 4. It is in the form of mx plus c. So slope means this one. So this must be same for set of all those lines. So y is equal to 2x plus 4. So set of all lines which are parallel to this means we need to keep this one as constant means this should not change. The slope should not change, but our x-intercept, c is nothing but our x-intercept. So if we go on varying the x-intercept means what and all the lines we are going to get, that will be parallel. So if I take mx plus c1, mx plus c2, so on means all these lines are parallel to each other because it is having the same slope, but x-intercept is going on changing. So all those lines parallel to this line means y is equal to 2x plus k, where k is belonging to some real number. So this set of line is parallel to the given line y is equal to 2x plus 4. So this is what they have asked. We need to find the set of all lines. So this is the set of all lines where k is belonging to the set of real numbers. So set of all lines which is parallel to the line y is equal to 2x plus 4. So this is regarding the exercise questions. So there is two questions from this exercise based on MCQ. I hope you can solve those two questions with yourself by knowing the reflexive, symmetric and transitive concept. It is very simple. Suppose if you didn't get, you can ask me at any time. So these are regarding the exercise 1.1. If you have any doubts, you can ask me at any time. So one thing regarding this chapter I need to mention is that please, if for any questions, once finishing upon the concept, if you are about to solve the question, any exercise question, means first read the question, try to solve this question with yourself, later play the video and look into the video how that question is solved. At that time you will come to know, or you will come to understand what you peoples are thinking and how that questions is about to solve. Unless and until you will not understand the difference between what you people are thinking and what I am used to say. So when you understand the difference between those things, if you are thinking and what the idea is there in this video are same, means then you have understood the whole concept up to 80 to 90%. I can make it show. Okay, so the thing is, if you are solving any exercise question, try to solve it first by yourself, later play the video, then compare your idea with what I have been explained. That's all I need to say. So thank you guys.